you would have other components on your PC. You would have interrupt controllers, and you would have other chips that deal with direct memory access and other components involved in a mainboard and a mainboard functioning. If you look really close, can we get a close-up here? You want to look at the system bus. Can you see these lines here? Look down and see these lines going through the mainboard. Those are called traces. What they are is they're tiny little wires or connections built into the silicon in the board, in the circuit board. Are you able to zoom in on that? But when we talk about a system bus or bus, what we're talking about is actually physically those traces, those wires, being able to carry data. And we talked a little bit about memory in this week's lecture, how 8 bits go into a byte. So really everything is done in terms of 8. So 8, 16, 32, 64, 128. More sophisticated mainboards, more expensive high-end mainboards will have a higher bit capability in terms of the data that they can move or transfer. All of this factors into the performance of your PC. It's not just the CPU frequency that your CPU oscillates at. It's not just the amount of memory that you have, although those definitely help, but it's also the bandwidth, the number of traces, bits and bytes that you can move across your bus at one time. All of that factors into performance. Now, back to the CPU. CPUs basically have an instruction set, and there are many different types of CPUs, but they generally have a buffer that can hold information. 2 megabytes, 4 megabytes, depending on the type of CPU, its brand and category. We'll talk about that in subsequent weeks. They do all the processing, the calculation, the mathematical part, which is any type of computation. They work directly with memory, and in this case the combination Northbridge-Southbridge chip here, but basically what happens is they have to take information off of what we call secondary storage, which is non-volatile memory, like a hard drive or a flash ROM chip. They move it through the Northbridge, down the traces into the CPU. The CPU does something with it, and then it will move it into what we call primary storage, which is the RAM, the random access memory. Random access memory is much faster than secondary storage, like a hard drive or flash ROM. But it requires continuous current. It has to be refreshed, or the content stored in that RAM, that memory, will be lost. So that's why if you haven't saved anything on your hard drive and you don't happen to have a battery backup system or UPS and your computer cuts off, you lose everything. You lose what you've been working on for the last 10 or 15 minutes because it was in primary storage in RAM, but it had not been saved to secondary storage. So without electricity, information cannot be stored or cannot be retained in RAM and primary memory. Now that's not the case with hard drives. Hard drives use magnetic lines of flux on metal platters, and it can retain the data without electrical current. We've looked at the different components. Let's again look at the mainboard. Here's a CMOS battery, and this just connects the different components of the front panel, the hard drive LED and the power switch, the reset switch. It's a couple of jumper switches, hard drives. Let's look at some of these components closer up. This is an IDE hard drive, and here's a 40-pin cable if you look on the back, and here's where the Molex cable will go. This is a jumper. Hard drives generally need to be designated as master or slave or a setting called cable select, and you can do that by pulling the jumper. I always recommend keeping a little bit of a fingernail if you deal with jumpers a lot, but you can simply move the jumper, and by shorting out different terminals, you can change it to master or slave or cable select. And what that does is, when a hard drive is connected or daisy-chained together with another hard drive, it allows it to be read properly in the CMOS by the BIOS, configured with the number of cylinders and heads. Some of you are wondering, what's daisy-chained? Well, daisy-chained is when you have one IDE port like we have here, we have 2 drives connected to it. So I have a hard drive on the same cable, one cable. I have a hard drive connected here, and I have a DVD CD-ROM drive connected here, and that's connected to this IDE port, which is our primary IDE port on this main board. Now, here I also have 2 drives daisy-chained, 2 hard drives. This is on my secondary IDE port, and I have a hard drive here and a hard drive here. If you look at an IDE cable, the longer end usually plugs into the main board, and then these 2 can plug into different drives. So, of course, a newer system, you'd have serial ATA. Serial ATA, you can only attach one drive to the cable, but a lot of the newer mainboards may have 4 serial ATA ports. Most mainboards only have 2 IDE ports, but you can daisy chain, which means you can take 2 hard drives or 2 devices and put it on that 1 IDE port. So a total of 4 devices, even if you only have 2 ports. If that's not enough, you can buy expansion cards that will plug into a PCI slot and give you more IDE ports, more capability that way, or drive controllers. Let's see, hard drives. Let's look at an older mainboard and get a little bit closer look here. Here's the CPU without the heatsink. Okay, I removed it. That's the thermal paste that's left over, and it's kind of gooey, some silicone paste in there, and it just helps transfer the heat or conduct the heat from the top of the CPU, the metal cover over the ceramic, into the heatsink, which would then dissipate it, and the fan would blow cool air over it and help dissipate the heat. This is called a ZIF, or Zero Insertion Force Socket. This is a Socket 7 older mainboard, AMD model. A ZIF, Zero Insertion Force Socket, is to help you when you're inserting the CPU or sensitive component. If I gently pull the lever, the CPU comes out like this. And again, you want to make sure you either are standing on an anti-static mat or you've grounded yourself so that you're not killing anything with static electricity. But I can pull it out with very little force, and that's a good thing, because if you look at a typical, and this is an older CPU, modern CPUs many times have more pens that are more fragile. But these pens are very small and very fragile, if you can see them. They're tiny. Look at it next to my finger. You can see how tiny they are. They bend very easily. And if you bend them, occasionally you might bring it back to life with a pair of very fine needle-nose pliers or some tweezers. But generally what happens is they'll break off and it's ruined. Your CPU is gone. That could be one of the more costly components to replace on your PC. So the ZIF is a very useful device. It keeps you from damaging the CPU when you insert it. Now if you look carefully, it looks like everything's the same, but you'll notice one corner of this CPU is not perpendicular, like a 90-degree angle here, here, and here. But notice here, it's diagonally across like that, sort of catty corner, or folded. Well, that lines up with this. If you look at the ZIF socket, see how 90-degree, 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 but here, that's a 45-degree turn right there. So we want to line those up, and I'm just going to take it, when I change CPUs or upgrade or put one in, I don't want to put a lot of pressure on it. So I'm going to just let gravity hold it, and I'm going to slide it very gently till it falls into place. And then I want to take my ZIF and gently push down on it, and there's a metal plate in there that will move out across those metal pens, and it connects to it. And that connects it to, if you can see, all these little traces on the mainboard. See, they're all going to each one, those different pens on the CPU. I've got thermal paste on my finger now. Those different pens, and that's where the bits and the bytes, those little 8 bits to a byte, get sent and processed through the North Bridge to the memory and back. Okay, in this case, this heatsink here is covering our North Bridge chip. This is typically a BIOS chip. It's EEPROM, so it's non-volatile ROM memory. And you read in the book in chapter, I think it was chapter 1 or chapter 2 about BIOS or EEPROM, but that's an instruction set. It gives your computer the ability to go through what's called the POST, the power on self-test. Just a very basic set of instructions that allow it to communicate with hard drives and other pieces of hardware so that it can, or maybe a PIXI compliant NIC card, but simply so that it can find an operating system and start the boot process. We also have a few other expansion components here. This is a video capture card and television card. And you can plug these into your computer and basically use your computer as a television or watch it in a window. It's PCI. You can see the interface is the same here, PCI. This